Alright, so on Friday we were talking about conditional probability, but we were using the two-way frequency table. Today we're going to do conditional probability, but we're only going to use the formula. Okay? As a refresher, conditional probability is when we put some special condition or limit on the sample space. Okay? Remember that you can write conditional probability using the notation probability of A given B. That line there between A and B means given. Okay? So, looking at the formula, it's still the same concept from Friday. Okay? Same thing we were doing, but this time it's mostly going to be in words. So we have probability of A given B is equal to the probability of A and B divided by the probability of B. Okay, so recall from Friday, it says yesterday, but whatever. The two-way frequency table shows the number of boys and girls who are working on the school musical and whether they are performers or stage crew members. Alright, so what is the probability that a randomly selected student working on the school musical is a boy, given that that student is a member of stage crew? Alright, so we have the probability of boy, given they are a member of stage crew. On the top of my fraction, I want the probability of boy and stage crew. Okay, so I go on my table to boy and stage crew, which will be 18. Out of the bottom number will be the total number for the second half. So the total number for stage crew, 18 plus 7 gives me 25. So my fraction will be 18 out of 25. Alright, on Friday we left these answers as fractions, but remember that that probabilities can also be written as decimals or percents. So we're going to do 18 divided by 25, and that's going to give us 0.72 as a decimal. Okay, so this is what we talked about on Friday. So looking at example 1, this is still the same stuff, okay, but this time it's not a word problem or a frequency table. Instead, it tells me the probability of B is 0.3, and the probability of A and B equals 0.2. Find the probability of A given B. Okay, so using our formula, the probability of A given B is equal to the probability of A and B divided by the probability of B. Right? We don't have to memorize this formula. It is going to be on your formula sheet, okay, as well as the multiplication rule. Remember, the word and means to multiply. Okay, so probability of A and B, 0.2 is on top of my fraction, over the probability of B is 0.3. 0.2 divided by 0.3 is going to give me 0.67. Alright, so looking at example 2, we have the probability of B equals 0.4, and the probability of A, and then that symbol there is intersect B, equals 0.24. Find the probability of A given B. Okay? Anytime you see this symbol here, the intersection, that's the same thing as saying the word and. Okay, so we still have all the same information. The probability of A given B is going to be equal to the probability of A and B, which is 0.24, divided by the probability of B, which is 0.4. 0.24 divided by 0.4 is going to give me 0.6. Alright, so on the back side of the paper, example 3 is a word problem. We're going to look through all of this and get the information that we actually need to figure out the answer. Right? A survey of college students was conducted, and it was discovered that the probability that a college student works full-time is 0.56. The probability that a student is male and works full-time is 0.43. What is the probability that a student is male given that they are working full-time? Okay, so what we know from the problem, the probability that someone works full-time is 0.56. The probability that someone is male and works full-time is 0.43. All right, what the question is asking us is, what is the probability that the student is male, is going to go first, given that they are working full-time. Okay. So on the top of the fraction, I want male and works full-time, which is 0.43, divided by the probability that someone works full-time, 0.56. 0.43 divided by 0.56 gives us 0.77. Okay, so looking at example 4, it says the senior class is 55% female, and 32% of the class are females who also play a competitive sport. What is the probability that a student plays a competitive sport given that that student is female? Okay, so we have the probability of a female is 55%, which would be 0.55. And the probability that a student plays a competitive sport and is female will be 32%, which is 0.32. All right, so if we have the probability that a student plays a competitive sport given they are female, then we're going to set it up 0.32 divided by 0.55. Okay, you should get 0.58 for your answer. And just a little bit of a tip here on this part, okay? Whenever you're dividing, okay, if you flip these and did 0.55 divided by 0.32, you're going to get a number bigger than 1. Okay, and we can't have a probability bigger than 1, okay, because if we change that to a percentage, you can't have bigger than 100% for a probability. Okay? So, looking now at example 5. It says the two events, A and B, are such that the probability of B equals 0.2. The probability of A given B equals 0.1. Find the probability of A and B. Okay, so using our formula, the probability of A given B equals the probability of A and B divided by the probability of B. We're going to plug in the information we do have. So the probability of A given B is 0.1. On the top of my fraction, I have the probability of A and B. I don't know that, so I'm going to leave it written that way. On the bottom of my fraction, I have the probability of B, which it tells me is 0.2. So I'm going to come down my paper sum and I'm going to solve for the probability of A and B. Okay, so to solve here, the first thing that I need to do is multiply both sides by 0.2. Alright, so multiply by 0.2. These cross out on this side. I'm left with the probability of A and B. When I multiply 0.2 times 0.1, that gives me 0.02. So we had to kind of work backwards on that problem there.